Yeah, perfect. Thanks a lot for joining us for session 9 of our Design Patterns course. Let's go for the next slide. So, to remind you who is the center of this course, it's me, and I'm sharing everything regarding to my career experience, which is not related to my current role. And I've built like 10 years plus of experience of coding with different design and backend systems. Today, your host will be Sonali, who will share with you the main pattern, leftovers, that we have. And she has already 14 plus years experience. And she built a lot with classic patterns as well. So it's very good experience that we can share here. And thanks a lot, Anne, who joined us recently to volunteer for this track, who also helped us a lot with presentation and content. Okay, let's go to the next slide. So let's do a brief refreshing. Last session was quite intense, but let's start with what is chain of responsibility pattern useful for? Yes, Dennis?
Hi everyone. What I understood about the chain of responsibility is that it helps the loose coupling, and one of the examples that stuck with me was when you have a customer service center and you have support staff, which they do their own work. So nobody needs to know the exact work that the one of the support staff is doing, and this is helping. Well, they all work with the customer support, but they all could have a different roles, a different departments they cover, different categories they cover. And also the book had a very nice example about the vehicle services, so separate type of cars and separate type of objects they could have. um, they could come from the same base, but they could have a different actions and responsibilities which they do not intercept, but they still are part of the base, part of the vehicle.
Mm-hmm. 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 Yeah, so basically we have chain of entities, actors who can get request and drop it or pass it to next actor. Yeah, like it's very good example indeed with customer support. We do a lot of different handlers of request. Thanks a lot. Yeah, thank you. I'm happy that you could memorize this example with customer support. Okay, let's try with mediator. Who would like to take this one? Yes, Pradna?
So, mediator, the example was that of the air traffic controller, and basically the idea is when there is a lot of traffic going back and forth, you need some kind of a gateway to coordinate the flow across, and that's what the mediator pattern that's where it will be useful.
Mm-hmm. Yeah, that's correct. We also can say that mediator pattern do something opposite to our single responsibility principle, because instead of having different actors to be responsible for their behavior, we put behavior of different actors in one single class, which now has a lot of knowledge about different actors, how what to invoke, when to invoke. If this, then we invoke this behavior. However, that's indeed the pattern that can solve problems when we have very complex system and we need to coordinate them. And good to keep in mind as well, orchestrator as a system design pattern, which is right now quite popular analogy of this pattern. Yeah.
Middlewares would also fall in that. category, is it?
Yeah. Okay, thanks a lot.
Okay.
Okay, let's try with bridge pattern. Who can explain? Okay, let me remind. So the idea about bridge was you have already some functional that you think will do the case, but then you notice that you inherit some behavior that's going to change. However, you inherit it from the interface that's going to change separately. So basically, you just need one more step to decouple them, and that's called to put them in different entities and build the bridge between them. So bridge pattern is more like composite pattern, where you say, instead of inheritance, this will be my field, and I will get it through composition. So that's very simple, actually, concept, but wrapped in the whole pattern. I would recommend to think about it. Just the principle. Get composition, value composition over inheritance. Instead of inheritance, find out how could you use this class instead of extender to be just a field. And if you would read ever Josh Blocher, Effective Java, you will find the same principles. That she's like, they say there are so many mistakes in core libraries of Java when they used extend hash table, something like this, extend this, extend this. Instead of it, they could just use field in this class. And if they need this behavior, they just invoke methods from the field. They don't need to extend this behavior. So value composition over inheritance. And memento pattern. Anyone would like to take this? Yes, Dennis?
If someone else is wanted, it's okay. I just the memento pattern for me, the easiest way to understand it is with so we want to introduce history of our object, and we want to be able to in time go back or revert. And the way I could have understood is with the text editor and having undo or control Z if you want to revert back the history. So having a history and allowing the object to, maintaining a history of the object status of and status, not really status, not like the machine status, but it's just a history of the of its life cycle.
Yeah, anything, like anything that was previous snapshot.
Snapshot, exactly.
Snapshot of our system, of our classes, of our entities. We just wrap it in Memento. Yeah, that's absolutely correct. And again, right now, any snapshots analogies would be like evaluation of this pattern to bigger design, to high level. Okay, thanks a lot for your answers. Now we go to the next slide, yes, and we start with visitor. And here I pass my imaginary microphone to Sonali, and I leave you like this. But I hope that session will go very well and you will enjoy it. And videos we prepared some videos. If there will be some technical issues, no worries. It's just, don't stress. Don't be stressed.
No worries.
Yeah,
Thank you,
okay.
Nina, and I'll continue with the visitor pattern and all the patterns today. So first we'd like to talk about the visitor pattern. This is an example from the book where it was mentioned that we talked about the diners and the pancake house. So some new requirements have come in and want to add some more details at the menu item and the ingredients level. So the visitor pattern come in handy, specifically when it's the composite structure is in place. So here we will see that in the book that uh, it talks about how the visitor pattern is important to not just change the core implementation of the nodes. So here we will talk about specifically that visitor is helpful for to maintain the hierarchy. So we don't want to change anything in the structure of the nodes, but actually we want to add more behavior. So in that sense, it is crucial and to think about how we can use visitor pattern. So visitor pattern is basically leverages the composite's recursive nature to traverse the structure. And here it's important to consider that it'll be important when we are talking about visitor, we have an hierarchy and we just need to change some bits and add some operation to these nodes rather than change the whole object inside. So if you see in this, they were talking about that this was a proposed solution where they might have to add new methods to the menu item and the ingredients class both. But here is how we can implement a visitor pattern and get the information from the objects itself and then add the details or get the details specific to menu item or ingredients. Just to continue, I'll share my another tab. One second. So let's refer to the raccoon. If you see in raccoon also they are using a similar example of an XML. We have to develop an app that works with the geographical information, and each of the graph represents a complex entity. So if there is a link, then the nodes are connected. Otherwise, if there's no node between the objects, then each node will typically be on its own class. So the problem here was to how we don't want to actually alter the individual classes, but there would be a solution to implement something like if I have if it's a city, then I want to have specific implementation, and if it's an industry, then I want to have a specific implementation. To do this, then there comes a another important pattern called the visitor pattern, which is again is a more of a behavioral pattern rather than a structural pattern because we are changing the behavior on runtime rather than when we are structuring the whole solution. Let's go to the Java example. From the complexity perspective, in my experience, I've never used visitor pattern. I'm not sure if somebody would like to add into the chat that if they have used this visitor pattern in the past or they think that there could be a situation they would like to try it out. But this is slightly complex and you can see it's less popular as well. In the example, I think it was more about how we want to basically have specific implementation to differentiate. So we want to have specific implementation for a particular shape, say called dot, have a different implementation, and similarly another circle and so on. So instead of changing the dot class itself, the visitor pattern comes in and it says that, okay, just override this method and the visitor will perform the action based upon the shape. So this is what you can see that it is in circle. You will have something similar. You just need to implement what is in the visitor would perform for a particular circle operation. And let's go and see the visitor implementation. So this is the visitor interface, where we are defining that we would have separate methods for the dot, circle, and rectangle. And in the XML export visitor, we would have the similar implementation where we'll be defining that for dot, I would like to have its coordinates and implement and written in this way. For circle, I would like to mention the radius, and similarly for rectangle, width and height. So instead of changing and having these methods specifically implemented in the individual shape classes, we would like to introduce a visitor class that will perform these operations on those shapes. So this is an example from Raccoon, and let's go back. And this is the definition. So as I mentioned that we use the visitor pattern when you need to perform an operation on all elements of a complex object. So basically, as I mentioned in the beginning of this pattern, that the for visitor pattern, it is crucial to have a composite structure, and the visitor uses the traversal nature of the composite, the recursive nature of the composite class to traverse the structure, and it doesn't change the structure at all, but add additional behavior or operations to it. So here is an example, a slightly simplified example, if we like to look at it. So if you see that, think about a scenario where a tour guide would be giving a tour about a museum, and within the museum it can have paintings and it can have sculptures. So basically, the guide has to talk about specific details of a painting and plus specific details of a sculpture based upon the room. As an example, when you go into the museum and you know that this section is only for paintings, so he will be talking about the artist and the paintings and the details around paintings. At the same time, if he has to go to the sculpture section, he has to talk about the material and different aspects of the sculptures. So herein we are leveraging the visitor pattern in a slightly different way, that the visitor is same, but his or her expression of explaining and visiting that particular room would change. So here you can see that this is the exhibit description the guide would talk about. When he would be visiting a painting, he would talk about the artist, and if he would be visiting a sculpture area, he would be talking about the material of the sculpture. So any questions so far? Perfect. So let's move on, and we have come start thinking about the system design analogies for the visitor pattern. So as an example, compilers are a great way to think that compilers use visitor-like patterns in abstract syntax trees. So basically, If you talk about in compilers, they have to deals with the different nodes. In there are some variables and operators and functions, and the visitor had to either interpret or optimize these nodes based upon their I would say their type. So this is how the visitor pattern would work on different nodes. As a key takeaway, the visitor pattern would be flexible to add new operations without modifying the actual structure of the composite nature of those nodes. So this is one example, and another very interesting example you can think of is a monitoring system. So think of monitoring tools that would collect matrices from different resources, and here the monitoring tool would act as a visitor, because each resource type would accept the visitor and provide their specific metrics to be showcased on a dashboard. So the visitor basically the monitoring system is enabling the collection of matrices without any alteration. Uh, Something like CloudWatch. Yeah, exactly. So CloudWatch is a type of monitoring system, and you can think of Grafana as one example. Grafana uses same. They use tons of different data stores, and then they can populate those information from different data sources to create a very simplified dashboard that you can see. So in that sense, the monitoring system is basically performing different um, tasks based upon the resources. So some of the data could be coming from a database directly, or some of the information could be, I'm just thinking, that can be feed into like a CSV as well. So how monitoring system would be acting specifically based upon the resource type is how it uh, come and show you the complete dashboard in sense. And that was all about the visitor pattern. And if you can think of more system design, we would love to hear as well, like in different contexts, in real life world examples as well. Like these were some of the examples that come to our mind, and you work on the daily basis within your work. So second design pattern that we are going to talk about is Flyweight. Um, it is an interesting pattern, but just a disclaimer, it is not something that you would like to uh, implement until you have a certain scenario, like until you um, are not considering any memory degradation or something like that. So you would like to avoid this design pattern. But if you are looking for a design pattern to optimize your memory, then this is a design pattern you should consider. Uh, let's see a very interesting video that might help you to just think in a different way. Mm. So this is so if you can see from the video, so it was one of I think most of us, if we are from that era, we would have played something similar. So here it's a key thing that if you will notice, the objects have different colors, and they could have different positions as well. And what this flight weight pattern would be. Just sharing the screen again. Yeah. So how flight weight pattern can be correlated to this particular game is that repeatability, and the core thing of or you can say the intrinsic state of those objects were shared, and but the underlying object was different. So you can see that the green, I would say the helicopter, something that was shooting, were the same, and we were reusing that. So in the book also they have used some a very simple example, that if you want to add trees object in a landscape design application, so you would think that okay, I would have like hundreds of trees around this house and I would create 100 tree objects. But this is uh, a thing that user might want to have lots and lots of trees, and you this is the time that you need to consider that how I can optimize it, and if my number of objects are too many, how I can leverage the change, what is changing, the intrinsic state of the object, and try to use a flyweight pattern in the correct way. As I mentioned that if you see in upcoming slides as well, it talks about that it's good to use this pattern when you are trying to optimize your memory. So here it will, if you see it in the tree manager, it is trying to have a tree, a single state free tree object, and all the state of all your virtual tree objects are stored in here. So I think I've in the book it was a very interesting example as well, but it was not clearly defined or implemented. But in Raccoon, if you will refer the Raccoon example, it is quite more interesting and it's more clearer. So if you see, and as I mentioned, it is one of the structural design pattern, and it lets you fit more objects into the available amount of RAM, and common paths of state between the multiple objects. So as I mentioned that this pattern is going to solve a problem that if in as an example you want to have 10,000 trees, but you want to utilize a specific memory. So rather than creating 10,000 tree objects, how you can optimize it and use a similar RAM but fewer tree objects. But this is not the overall tree object. We would see that it is reduced some way, but some specific state within the tree object, that is the changing nature of the trees, would be shared and would be repeated, while the extensive state of the tree, like the coordinates and specific positioning, basically the positioning and other features that are crucial for tree, that would remain the same. So I think if I'll show you the example, they have a very good example. This tree one. Again, from complexity and popularity perspective, I've not implemented this design pattern, not thinking that it was a design pattern for sure, but we might, when I was going through some of the examples and details, every one of us would have used it how or the other, because we try to create a lot of maps. When we code, we try to create and reuse a lot of objects. So in some way we might have used it, but not in the sense that we are implementing a Flyweight pattern, and not in a holistic way. So that was my view. Like, I've never implemented in a straight way where I was thinking okay, that I need to optimize my RAM use storage, and I use something like that. But it is interesting to know that if we are in a situation like this, how we can leverage it. So here, it's a very simple example. You want to have a tree that would have its coordinates, and there are tree type, and the tree type would have its own properties, and then based upon that you will draw your tree with this, with the coordinates and stuff like that. Now the interesting part, or you can say and see, that the shared state of the several trees is the tree tribe. As I was mentioning, here we would like to um, you reutilize the concept or the memory in the sense that let's create something that can be reused, rather than creating tons of objects. So if just think that if you want to define a tree object, a tree class, and you would have a name, color, and just the simple name and color, then every tree, you would have to create 10,000 tree object if their coordinates are different, but even their name and color are same. Because their coordinates are different and their name and color are same, but that would have been 10,000 tree objects. How this example has optimized it is that they have created a factory, a tree factory, where they would be creating something like a map, and all the tree types would be in that map. And now you can think in this example that your tree type would be referred from this map rather than an actual tree type object. So, as an example, you could have a pine tree and an oak tree. And if we create two tree types, then we will just have two objects in this map. And those informations, the information of the type of the trees could be directly used from that map, rather than creating tree type of objects for all those 10,000. It is good to have that as a factory method, and then you can reuse those. So in this, if you go through this example, it says that, okay, now let's build the forest. And when it is trying to create the type, it takes it from the tree factory. So, example that you want to plant a tree which is has different coordinates, uh, and an oak tree, but and a green oak tree. In this example, it would create one tree object of coordinate um, 1 and 2 as an example, and then oak. And then, and second time you have another different coordinate, but same oak tree and same green color. Then in that case, it's not going to create another tree type object, but it would actually refer again the tree type object that was available in the tree factory already. So this way, if you see and run this, you can see uh, how the RAM usage stats that they have given has optimized. So instead of using a 36 MB storage to generate this, they were just leveraging a 7 MB storage. And it was just to think about in Flyweight pattern is think of the intrinsic state of an object that can be shared and try to have a factory method in this case, or a simple map, just to get that shared data. And then and specific properties like the coordinates of a specific tree are outside the shared object, and that needs to be passed as an argument, and that has to have an individual object of its own. So this is quite interesting pattern, but something that we might only use in a specific scenario. Yeah.
I was wondering, some languages have an enum, where you can store different types. Is that an example of this pattern?
You can use enum as in type, but as I mentioned, you will be using, you're not creating the enum type object again and again. So Flyweight would be leveraging, in this case, it is leveraging a map, but yes, you can leverage an enum as well in the same way.
Thank you.
As I mentioned in the start, that use a Flyweight pattern only when your program must support a huge number of objects which barely fit into available RAM. So this is crucial because maybe we need to evaluate the performance as well. Are we doing an overkill? Like if we have like very few objects and we are trying to implement something like that, is it useful? Or in a scenario where we have to create, like we as an example in this case, 10,000 of tree objects, what shared data or what shared data could be leveraged and created as a different shared data can be created in a factory method, and that can be reused and reduce your memory storage. Analogies for the Flyweight pattern in real life or in Java, you can think of as a very important concept we know in Java is string. So Java uses a string pool, and basically, sorry, 1 minute. And when you create your, say, suppose a literals like hello, so instead of going and creating another object, so string uses this shared pool and try to get that string literal from that existing string that is already defined. And as we know, strings are immutable, so which ensures that the shared instances in the pool cannot be modified. And is in this you can see that when you use hello in like string s is equal to hello and another string, so it is actually using the same reference. And if you are using the extrinsic property of string would be if you are using in a different context, and it would be like two different places, maybe completely different areas. So that would be the intrinsic property. And here you can see that when you actually create the string with something like new string hello, in that case only it would create a new instance. In this case, it's not using your shared pool. It is actually a new instance that is outside the pool. Another system design concept that you can think of in if you're thinking of Flyweight pattern is the, again, database connection pooling. Here you can think of like we have when you're building your application, you will have pool of database connections, and those can be reused without creating and destroying the connections repetitively. So it would be slower. I would say it can slower your application if you are like creating a connection, then closing the connection, and then rebuilding it again. So a good approach would be to use a database connection pool and request the connection from the pool whenever it's required. Another example is I think, yeah. So, sorry. So another example, and a very interesting one, similar to the video that we saw before. Like if you can see here, these design applications, you would see that they will be using a same object. The only thing that would be changing for them would be the color. So these sort of applications would be using a Flyweight pattern for sure. So you can, so whenever you are thinking of Flyweight pattern, I think the best way to remember it and reuse is how these design applications would be reusing the components in the optimal way. Otherwise, if they have to create like doors of different colors, as an example, window doors or something like that, then they would be, instead of creating uh, uh, 8 and 10 objects, they would be using some shared data that the structure is same. Only thing is changing is the position. Otherwise, the name of the window panel or your curtain and everything would remain the same. Any question before we move on to our third pattern? Yeah. So let's talk about third and the last pattern for today, the interpreter pattern. This is an example from the book. So in you will find that it's slightly for me, it was slightly difficult to understand how it can be a pattern, and how are we really using this pattern in a real life scenarios. I don't know. I might have never built a query language, like um, a language, a symbolic language that is interpreted by a system, and then you are generating it. So something that is, I have never done it, but it will be very interesting for me and for all of us to know if somebody has done it in their experience. So in the book talks about duck pond simulator, and if you see how basic command like write while daylight, fly otherwise quack, and something like this, how they have changed into something like a small program that would talk about an expression, a command, a sequence, and a repetition. So, and then define these grammars individually, what the specific sequence would be, what these commands would be, and something similar to this. And then this is the class diagram. This is the representation how an expression would be a combination of some repetitions and sequence and variables. And you can see that interpreter pattern represents for its, like, or whatever we have defined here, the grammar, they are representing similarly in the class format. And each you use the class to represent each rule in the language. So this was just the example from the book. And if you see what happens, 404. So raccoon do not have anything for the interpreter pattern, maybe they don't consider it as a pattern, but yeah. So which is interesting to see that in, as I mentioned, that I have never implemented something like this in my experience, and for them, it's nothing. It's not a pattern as is. For an example, we have worked on an example that might help you. Just a second. Here, if you see, for us, the expression is to interpret what we are passing, and then you need to interpret uh, whether it's a number or an operation. Sorry, an operator. So here, if you implement the expression, it will say that this is a number and it's going to return the number. And then you have another implementation of an add expression. So you want to say something like, I want to add two numbers. Then what would be the grammar for that uh, um, expression? So you would actually add the left expression plus the right expression, or you can say the left hand operand or the right hand operand in this case. But it can actually, when you are writing something like this, um, I think somebody mentioned something. Yeah, yes, exactly. So, yes, this is an example of a calculator that they're trying to build. And as I mentioned, when you're writing your interpreter, you need to think that your add expression can actually just be an operand, or in this example, as it says, it can be a expression itself. So let's see. Uh, similar to a subtract, but your interpretation would be slightly different, and you can again add more complexity and more rules to it. Like in case of a subtract, I would like to have, maybe it should always be a non-negative subtraction or something like that. And if it is and always it has to be left to right, or some sort of conditions. And then when you're actually creating this expression, what would be the result? So this is an example where you see that the interpreter pattern is working, where you are saying that, okay, I have two numbers. That was one expression, my left expression and my right expression. And then you interpret the expression for the add operation, and then you do the subtract, and then these are your left expression, right expression, and then you're complete. So this is an example where you, a very very simplified version, I would say, where you want to build your own grammar and your own interpreter with some rules. Interestingly, I don't know if a lot of you know about it, anything about the Morse code, and how interestingly this was used in the past. So it was very interesting to know that how these code, just to give you a short history, so this was developed in 1830s and 1840s, and it was widely used for long distance communication via telegraph systems. And the dot you can see represents a short signals, and the dashes were used for the long signals. So this you can see, think of like how they would be interpreting this particular signals to coincide with the actual alphabet. So it involves the translating of this symbol to the actual alphabet. And a very interesting video, if you see.
You're not sharing the tab if you've gone
Oh.
to the video.
Sorry.
So-
Can you see now?
Anchorage. Stop. Repeat urgent request. More diphtheria antitoxin. Stop. Gnome in grave danger. Stop. Please help. Stop.
So just think about how the dog was able to, just from the ticks, was interpreting. So it was his interpretation what that signals were about, what he wanted, because maybe he is not understanding the language he's talking, but he knows what those tick 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 was. So that is a very interesting video about how different people would interpret different things. And this is something how you can think of some real life examples. A compiler, for sure, you would see that different languages use compilers to interpret different things, and you would give compiler errors and all sort of stuff based upon only that you have an interpreter already. And then an interesting example, sorry, an interesting example to think about is GraphQL. uh, so if you have worked with REST APIs and you know GraphQL, so GraphQL you can just think of a layer in between client and the actual backend REST APIs. And if suppose the client has to request a user information and a user order information, then the GraphQL will go in backend and interact with not just one but two and multiple APIs and give the client the details required. So here GraphQL can be a slight smarter version of interpretation, that what is required, go and fetch that information. Not entirely, but slightly, just to understand how it has interpreted the request to the actual response from the multiple REST APIs. Again, Terraform is an example of interpretation of configurations. So each and every resources on cloud are written in Terraform. So structurally, Terraform has the same language. They are using I forgot the name of the I think it's CL or something. They use the language they call, but it is interpreting the particular provider resources. So that's interesting to understand how you can think of interpretation or an interpreter pattern in a different context of system design and different components of engineering. Another example would be like ad feeds. So think of these ad feeds templates that would be created. I'll just zoom a bit. Well, so I was just trying to zoom this if it helps. But if you see a marketing manager would actually say that, okay, I just need to define the rules to generate the feed. And that feed would be actually generated based upon a DSL. So these DSL are something that a developer would write for these marketing managers, so that they do not come. So think of a developer who doesn't have to change something in this code. Say example, the marketing manager wants the red cars, and and only the red cars as an example, for a 1 day of promotion or promoting their content. Next day, they could say that, okay, I want to filter another type of vehicle and a different color. So in that sense, you either you have two options. You build a front end to automate and create these rules and change these rules, add more parameters every time. Or if you are running out of your front end resources and you want to build a simpler version and not more complex, you can actually think of creating a DSL where you will have something similar that we saw in the starting, an expression that would say that when you have a title, just pull the data from this field. When you have a description, pull the data from this field. And then for your marketing manager, it is easier to change the details. Like for a title, I want this, and then uh, the feed to be generated is just have to parse that DSL to the data store, and the CSVs would be generated, which would be nothing but these ads feed templates that they were after. So this is another example of interpretation and how you can use it. So this is what we have to cover so far today. If you have any questions for any of these patterns, feel free to ask. And I'll just walk you through what we have covered so far. So I think Irina has done an amazing job in covering most of these patterns, and I think I personally I feel that this book gives a lot more details around, and a focus. I would really say a focus around how you can think of solving a problem through different design patterns. And this is where we are. In the last session, we did some of the additional patterns that we discussed in the start, and today we just completed the visitor, Flyweight, and the interpreter pattern. For the next session, which would be our last session, we would be talking about combining patterns and MVC. And the 11th one, which is the celebration that will be doing, that will be somewhere in January, and the event would be published soon. We have a something for the next session. So if you can just prepare slightly for the next session, read about how to combine patterns, and try to implement some of the patterns yourself, and think where are the challenges, what are the good parts of certain patterns, and some there could be tons of discussions that can come out of that as well. And read about MVC as well, and read about the patterns in the real world. So this is just for closing the next session that we wanted to do. So it would be really helpful for you as well, that if you have just a slight bit of an idea around those. These are some of the references, and as I think most of you know, that we were covering most of the patterns defined in the head first design patterns. If you have any questions, the floor is open. You can ask, and I'll try to answer those questions. Or if you want to ask it in the chat, then yeah, please do.